Hey guys, and welcome back to another video on the channel. In today's video we're going to be doing this question that has been given to me by a student, and we're pretty much going to be solving it. So the triangle PQR is inscribed in the semicircle of a radius 4 centimeters as shown in the diagram below. All we need to show is the area of the shaded region in centimeters squared is, well, A, I assume is for area, is equal to 16 multiplied by pi over 2 minus sine of alpha, where alpha is that angle as seen in that triangle. So the way we start this question is, let's just find the area of the semicircle. So the semicircle pretty much here. So an area of a circle is pi times the radius squared. Okay, we know the radius in this case is 4, but this is for a full circle. We only have half a circle, so the area of just the semicircle is going to be pi times the radius squared, which is 4, divided by 2. So you're going to have 16 pi on 2, which gives you 8 pi. So that 8 pi is that entire area there, pretty much. So if we want the area of the shaded region given here, we need the area of our semicircle, 8 pi, minus the area of triangle 1 and triangle 2, pretty much. Okay? Now, you can work out the area of triangle 1 and 2 using a particular formula. In trigonometry, if you have the following setup, where you know this side length and this side length, and you know this angle here, the area of that triangle is a half times that side length A times that side length B sine of that angle, pretty much. And as you can see in here, we've got that same scenario for both of them, except we don't know really what this angle here is at the moment, but we can work it out pretty easily. So this is a straight line, so that entire angle there must be 180 degrees. If that angle there is alpha, that means this angle here must be 180 minus alpha. So we've defined that now. So let's find the area of this triangle here. So the area of that triangle there will be pretty much using this formula here, will be area is a half times by both side lengths are the same, so we'll go 4 squared sine of that angle there, which is alpha. So that's the area of triangle 1. Okay. Now I'm going to move this stuff now to the side so I can write the rest of it. Move that over there because we don't need that at the moment. So triangle number 2 is the same setup. It's going to be this side length, which is 4, so area is a half times by side length are the same, so 4 squared sine of 180 minus alpha. Okay, so the area of the shaded region is the area of the semicircle minus the sum of this triangle, which in this case will be 8 sine of alpha plus 8 sine of 180 minus alpha. Now we're starting to get something like this, but we've got a problem. We've got this guy here. We only have it in terms of sine of alpha, so we need to break pretty much what we have in the green down into pretty much a single term with just sine alpha, hopefully. So we can see we've got a sum in here, so we can use sine's double angle formula. So if you have sine of an angle plus another angle, that is equivalent to sine of A multiplied by cos of B plus sine of B multiplied by cos of A, where A and B are the respective angles. So if I use this formula, I have sine of 180 minus alpha gives me, I replace wherever the A is now, I replace with 180, so I'll have sine of 180 cos of negative alpha plus sine of negative alpha and cos of 180. Sine of 180 is 0, so that term is gone, which just leaves me with this term here. Cos of 180 is negative 1, so I have negative sine of negative alpha. Sine is an odd function, so what that means pretty much is, if you have f of negative x, that is the same as negative f of x, if it's an odd function. Since sine's an odd function, that means sine of negative alpha is the same as negative sine of alpha. So we can replace that there and we'll get negative multiplied by negative sine of alpha, which just gives me sine of alpha. So we can replace this guy with just sine of alpha. So if I write that there, I just have sine of alpha. So add those terms together, so we have the area of the shaded region is 8 pi minus 16 sine of alpha. I can add them together because they are like terms. Now we can see, if I just rub this out so I have a little bit more room, we can see we've almost got our scenario here. If I multiplied the 16 in here, I would get 8 pi minus 16 sine of alpha. So to show that that's true, all I need to do is factorize 16 out of here. So the area is 16, take our factor so you get pi on 2, minus sine of alpha. And we have shown the area of the shaded region is that statement there. I hope you enjoyed this video. This was a student question. If you have any questions you would like to go over, email my I've got my email address in the description below, and it's in the details of my channel. So if you want a question solved or integral, just send it to that email and I'll hopefully solve it. Yep. Yeah, I'll see you in the next video then.